In this example, we look at hypothesis testing with two means. So our question that we're going to be investigating is this. Is the mean or average rent for a two-bedroom apartment in San Francisco significantly more than the mean rent for a similar apartment in Concord? We have compared means to numerical values. How do we compare means from two different cities? So step one is to determine the hypotheses and define our variables. When we write the rival hypotheses, we are making claims about the population means, so the variables need to be the population means. It does not matter which city we choose to represent group 1 or group 2, the choice is arbitrary. I'm going to say that mu1 is the mean or average rent for all two-bedroom apartments in San Francisco, and mu2 is the mean or average rent for all two-bedroom apartments in Concord. I'm using the Greek letter mu here because these are population means. Our null hypothesis assumes the two population means are equal. So there's two different ways we could write that. We could say H sub 0, which stands for null hypothesis, mean 1 equals mean 2, or the equivalent statement would be to say mean 1 minus mean 2 is 0. StatCrunch, when you choose a hypothesis test, writes it the second way. You can write it mean 1 equals mean 2, whichever you prefer. So notice there's two possible ways to state equality of means, either that the means are equal or that the difference in means is 0. This leaves us three possible rival claims for the alternative hypothesis. So if we use the greater than claim, there's again two ways we could write that for the alternative hypothesis. We could say mean 1 is greater than mean 2, or that's the same thing as saying if we subtract mean 1 minus mean 2, we're going to get a positive value greater than 0. Because if mean 1 is bigger, when you subtract, you get a positive value. The less than claim, we again have two choices for the alternative hypothesis. We could say mean 1 is less than mean 2, or you could say the difference mean 1 minus mean 2 is less than 0, because if you take a smaller number for mean 1 and subtract it from a larger number for mean 2, you're going to go into the negatives. And then our last choice is the not equal claim. So you could say mu1 is not equal to mu2, or you could say mu1 minus mu2 is not equal to 0. The difference is something other than 0. So, of course, the not equal claim corresponds with two tails on the normal distribution. The less than claim corresponds with the left tail, and the greater than claim corresponds with the right tail. So this whole setup is similar to what we saw when we were testing for two proportions. So we want to write the appropriate null and alternative hypotheses for comparing the mean rents in San Francisco and Concord. So our null hypothesis here is going to say mean 1 equals mean 2, and our alternative hypothesis says mean 1 is greater than mean 2. I chose to write these hypotheses the first way. You could definitely write it the second way as well, your choice. So step 2 is to collect the data. According to data collected by housing economists at apartmentlist.com, in May 2018, the standard deviation for all two-bedroom apartments in San Francisco was 630, and the standard deviation for all two-bedroom apartments in Concord was $740. We are going to treat those values as the population standard deviations. So we're going to assume that apartmentlist.com is reliable with their data. So researchers randomly sampled 34 of the two-bedroom apartments available in San Francisco and found that the mean rent of the sample is $3,064. Following a similar process, the same researchers randomly sampled 31 of the two-bedroom apartments available in Concord and found that the mean rent of the sample is $2,424. So we're asked, does the sample mean meet the conditions for us to assume that the normal distribution is normal or close to normal? Since this is quantitative data, we check that each group, San Francisco and Concord, have sample sizes more than 30. And so that is the case. San Francisco had a sample size of 34 apartments, and Concord had a sample size of 31 apartments, so that we can say the conditions are met. So now we want to record the variable values. We're going to use these when we calculate the formulas and go into StatCrunch. So N1 is the sample size for San Francisco, since San Francisco is group 1. So that's 34. X bar 1 is the sample mean for San Francisco apartment rent. So that was $3,064. Standard deviation 1 is the standard deviation for San Francisco. So we're using that assumed population value from apartmentlist.com. So that's $630. And then similarly for Concord, The sample size N2 for Concord is 31 apartments. The sample mean X bar 2 was $2,424 for Concord apartments. And then the standard deviation, again, using that value from apartment list and treating it like it's, assuming that it's the population standard deviation, that's $740. So now step 3 is to assess the evidence. So the z-score formula for comparing two means finds the difference in the two sample means and divides by the standard error for the difference in means. In order to use this formula, the samples must be from normally distributed populations with known standard deviations. So we have to have these known standard deviations that we're using from apartment list to use this z-score formula. If we don't have that information, if we're just relying on sample data, then we use something called the t-distribution that we will see in a different example. So here's our formula. You can see it's quite messy. This is the only place that I'm going to write it out by hand because I'm going to rely on StatCrunch to do this for us. So in the numerator, we subtract the difference in the sample means. So that's the $3,064 minus $2,424. So we get that $640 on top. That's the difference in mean rents, San Francisco minus Concord. And then the standard error formula takes the standard deviation of each city, squares it, and then divides by the sample size. And then we square root at the end after adding up. So that works out to be 171.2835. I don't like to do this calculation by hand. I make mistakes pretty easily with decimals and rounding, and you've showed me already that you can square and divide and add and square root numbers, so I don't need to check you in your basic arithmetic. So be good to yourself and let StatCrunch do this calculation for you. So to find the z-score here, we take the 640 and divide by the standard error, and we get right around 3.7365. So now we want to use a z-chart or StatCrunch to find the corresponding p-value. So if you're using a z-chart, you would go to the area on the left and get that out of the z-chart. So you'd come to the 3.7 row and then go over to 4 in the hundredths place because you'd have to round this 3.7365. And so you would get the area to the left is 0.9998, and then to find the area to the right, you'd say 1 minus that. So this is back what we did with the chart in the normal distribution chapter. We're going to let StatCrunch do this for us. So we're going to go into StatCrunch and select Stat, Z-Stats, 2 samples with summary, enter all of our data, and let StatCrunch do the Z-Stat and find the p-value for us. And those will match what we got by hand. So once we see doing this in StatCrunch, we're not going to try to do this by hand again. So here we are in StatCrunch. We'll open StatCrunch. We have summary data, so we're going to go to Stat, Z-Stats, 2 samples with summary, because we have all the values already given to us. We don't need to work with the data file. And so sample 1 is San Francisco. So I'll put in that sample mean, 3,064, and then the population standard deviation is the 630, and the sample size was 34 apartments. And then sample 2 was the Concord apartments, so the mean there was $2,424. The standard deviation was 740, and the sample size is 31. And then we are testing to see in our hypothesis test, let's go back and check. We are testing to see if San Francisco is higher than Concord. So we're going to use the greater than inequality in our hypothesis test here. And if you want to see the p-value plot, you can check optional graphs here. And then we go to compute. And you can see our z-stat is an exact match. Our standard error is an exact match for what we did by hand. And our p-value is showing a very, very small p-value, which matches what we would have gotten if we looked it up on the z table. And if we go look at the standard normal distribution, we see the same results. Okay, so be good to yourself and use StatCrunch. You won't need to do anything by hand for me. You've shown me already that you are good at subtracting and dividing and work in those formulas with the square roots. So go ahead and outsource that to technology. So step 4 is to state our conclusion. So this p-value is very small, less than the 0.05 significance level. We're using 0.05 significance level by default. The word problem didn't tell us a significance level to use, so we use that 95% confidence, 5% room for error, preferred value that we statisticians like. So we are going to reject the null hypothesis and conclude that the mean rent for a 2-bedroom apartment in San Francisco is greater than the mean rent for a 2-bedroom apartment in Concord. So if the two means were equal, it would be extremely unusual to see results like this. So this is telling us that we have good evidence to conclude that the mean rent for the 2-bedroom in San Francisco is greater than the mean rent for the 2-bedroom apartment in Concord.